Hi students, John here. Chapter 1 Application of Matrices and Determinants. Exercise 1.3, question number 1, subdivision 4. So first I am going to write the question. So first equation becomes x plus y plus z. So minus 2 can be replaced right side. So plus 2. So second equation can be written as 6x minus 4y plus 5z is equal to, so minus 31 goes to right side means plus 31. Third equation becomes 5x plus 2y plus 2z is equal to 13. So this linear equation can be written as in the form of matrix. So here coefficient of x becomes 1, 6, 5. Coefficient of y becomes 1, minus 4, 2. Then coefficient of z becomes 1, 5, 2. Then xyz matrix which is equal to, so constant value becomes constant matrix. So 2, 31, 13 is the constant matrix. Now I'm going to give the name for the matrix A. This becomes X, this becomes B matrix. By matrix inversion method, AXB can be written as X is equal to A inverse into B. So first I'm going to find A inverse matrix. So now I'm going to write A matrix 1, 1, 1, 6 minus 4, 5, 5, 2, 2. So now I'm going to find the determinant of A matrix becomes, so determinant of A is equal to, so determinant of 1, 1, 1, 6 minus 4, 5, 5, 2, 2. I'm going to give the symbol plus, minus, plus, then which is equal to, I'm going to write the 2 by 2 minor matrix in the form of, first I'm going to express first row. So plus 1 of, rows and columns will be eliminated, then remaining entries minus 4, 5, 2, 2. Then minus 1 of, the determinant becomes rows and columns will be eliminated, so remaining 6, 5, then 5, 2. Then plus 1 rows and columns will be eliminated, the remaining entries 6, 5, 1 times of 6, here 5, here minus 4, then 2. So which is equal to 1 times of first diagonal minus second diagonal. So minus 4 into 2 becomes minus 8, minus 2 into 5 becomes 10, minus 1 of 6 2s are 12, minus 5 5s are 25, then plus 1 of 6 2s are 12, minus 5 4s are 20, minus 20, here comes plus 20. So which is equal to 1 times of minus 8 minus 10 becomes minus 18, here minus 1 of 12 minus 25 becomes minus 13, plus 1 times of 12 plus 20 becomes 32, which is equal to, here 1 into minus 18 becomes minus 18, here minus minus positive 13, then plus 32, which is equal to, so 13, here minus 18 plus 13 becomes minus 5 plus 32, so this becomes 5, then 32, which is equal to 32 minus 5 becomes 27 is the determinant of A matrix. Then I'm going to find adjoint of A matrix. First I'm going to write A matrix. So A matrix is equal to 1 1 1, 6 minus 4 5, 5 2 2. So I'm going to write adjoint of A is equal to cofactor of A whole transpose A in இணைக்காரணிக்கு transpose எடுக்கணும். Okay, now I'm going to choose the formation of adjoint of A becomes adjoint of A is equal to, here plus minus plus minus plus minus plus minus plus, then entire minor matrix find out பண்ணதுக்கப்புறம் then I'm going to give the whole transpose. Now first I'm going to choose first element, so rows and columns will be eliminated, so remaining entries -4 5 2 2, then second element create rows and columns will be eliminated, then 6 5, then 5 2, then first order last element create rows and columns will be eliminated, so remaining entries 6 -4 5 2, then second order first element 6 create rows and columns will be eliminated, then remaining 1 1 2 2, then -4 create rows and columns will be eliminated, remaining corner elements 1 1 5 2. Second row last element 5 rows and columns will be eliminated, remaining entries 1 1 5 2, then third row first element rows and columns will be eliminated, remaining entries 1 1 -4 here 5, then second element rows and columns will be eliminated, here 1 6 1 5, then last element rows and columns will be eliminated, remaining entries 1 6 1 -4, then whole transpose. Now I am going to minimize, which is equal to, so first one plus of first diagonal minus second diagonal, so here -8 minus 2 5s are 10, here minus of first diagonal minus second diagonal 6 2s are 12 minus 5 5s are 25, here first diagonal minus secondary diagonal, so plus 6 2s are 12 minus 5 into 4 becomes 20 minus 4 here comes plus 20, then minus of first diagonal minus secondary diagonal, so 2 minus 2 becomes 0, then next plus 1 2s are 2, then minus 5, then minus of first diagonal minus secondary diagonal 2 minus 5, so next one here plus 1 5s are 5 minus 1 into minus 4 becomes minus 4, here comes plus 4, here minus of 1 5s are 5, then 6 5 minus 6, then plus of 1 into diagonal minus secondary diagonal minus 4 minus 1 6 are 6, then whole transpose, then which is equal to plus of -8 minus 10 becomes -18, here minus of 12 minus 12 25 becomes -13, then plus 12 plus 20 becomes 32, minus 2 minus 2 0, plus of 2 minus 5 becomes -3, minus of here 2 minus 5 becomes -3, here plus 5 plus 4 becomes 9, here 5 minus 6 becomes -1, plus -4 minus 6 becomes -10, then whole transpose, which is equal to -18 here plus 13, here 32, here 0, -3, here minus minus positive 3, here plus 9, here plus 1, here -10, then whole transpose. Now I am going to apply that transpose, therefore adjoint of A matrix is equal to so first row becomes first column -18 plus 13 32, second row becomes second column -3 plus 3, then third row becomes third column 9 1 minus 10 is the adjoint of A matrix. Now I'm going to find out A inverse becomes 1 by determinant of A into adjoint of A matrix. Here the determinant of A does not equal to 0, which is equal to 1 by determinant of A becomes 27 into adjoint of A matrix becomes -18 0 9 13 -3 1, 32, 3, minus 10. Then that is A inverse matrix. Now I'm going to find the inverse matrix inversion method I am going to apply here. So x is equal to A inverse into B. So x becomes A inverse becomes 1 by 27 of minus 18, 0, 9, 13, minus 3, 1, 32, 3, minus 10 into B matrix becomes 2, 31, 13 is the B matrix. Here I am going to multiply these two matrix, so which is equal to 1 by 27 of first row multiplied by first column. So minus 18 into 2 becomes minus 36. So 0 into 31 becomes 0. Then 9 into 13 becomes plus 117. Then 13 into 2 becomes 26. Then minus 3 into 31 becomes minus 93. Then 1 into 13 becomes 13. 32, next third row multiplied by column, first column. 32 into 2 becomes 64. Then plus 3 into 31 becomes 93. Then minus 10 into 13 becomes minus 130. So finally we get 1 by 27 of minus 36 plus 117 becomes 81. Then 26 plus 13 minus 93 becomes minus 54. Then 64 plus 93 minus 130 becomes 27. So here which is equal to this, can here 1 by 27 I am going to multiple inside. So 81 by 27 minus 54 by 27, 27 by 27. Then I am going to minimize, which is equal to 81 by 27 becomes, so 3 times of 27 becomes 81. So 3. Then here 127s are 27, 2 27s are 54. So minus 2. Then 127s are 27. So cancel, remaining 1 is the capital X matrix. So capital X becomes small XYZ matrix. So therefore X comma Y comma Z becomes 3 comma minus 2 comma 1 is the value.